Hey everybody, this is Virtual Mr. B. Today we're going to be talking about how to find values for sine and cosine from the unit circle. We're first going to review some special triangles, the 30, 60, 90 triangles. So the big thing to think about with these is that the proportions or the ratios of the sides of the triangles are always the same if you have a 30, 60, 90. The side opposite the 30 is x, the side opposite the 60 is x root 3, and the side opposite, or the hypotenuse, is 2x right here. So let's do an example. Let's say, so this is example number 1. So let's say that we have 30, 60, 90 triangle. Okay, and let's say the side over here is 7 right here. Okay, so the first thing we got to do is label the sides of the triangle that to correspond to our original triangle over here. So the side opposite 30 is going to be x, the hypotenuse is 2x, and the 7 is going to be our x root 3. So then from here what we can do is solve for x. So I would have x equal to 7 divided by root 3. Okay, so that means the bottom side here is 7 over root 3. And that means this side is 2 times 7 over root 3, which is 14 over root 3. And we're done. We solved the triangle. Let's look at example 2, 45, 45, 90 triangles. So the sides here, they're always x, x, and the hypotenuse is always x root 2. So let's do an example. Let's say I have a 45, 45, 90. And let's say the hypotenuse is 3. Okay? Well, we know that side, that 3, is equal to x root 2. And we need to find the corresponding sides, the x's. So what we're going to do is we're going to say x equals 3 divided by root 2. And there you go, we solved the triangle. So now let's get to the sine and cosine part of the lesson. So here I have a unit circle. And remember, a unit circle is a circle with a radius of 1. Okay, so the radius is 1. And let's say I want to find the sine of 30 degrees. Well, to find the sine, I need to take the opposite over the hypotenuse part of a triangle. Well, we don't have any triangles yet, so what we're going to do is we're going to draw a 30-degree angle. Okay? So this is 30 degrees. And I'm going to drop a perpendicular line straight down. And now I've created a 30, 60, 90 triangle. This angle has to be 60 in there. And since we're in a unit circle, the radius is 1. Okay, and now using what I know about 30, 60, 90 triangles, I can find out the other sides of the triangle. So let me extract the triangle out here. I know that the hypotenuse is 1. That has to equal 2x. Do you guys remember what side is opposite the 30? It should be x. So if 2x equals 1, then x will equal 1/2. That means this side down here is x root 3. So we're going to have 1/2 square root of 3. Okay, so now we can label this. So our triangle, this side is the square root of 3 over 2. I got that from the 1/2 root 3 down here. And this side is 1/2. So now I can find the sine of 30. The opposite side is 1/2. So if I'm standing on 30, the opposite side is 1/2. The hypotenuse is 1, and 1/2 divided by 1 is just 1/2. For cosine, I need to take the adjacent over the hypotenuse. So I'm going to take the adjacent side, which is root 3 over 2, and I'm going to divide that by 1. And so we'll get root 3 over 2. And there you go, we're done. Another thing to note is that this triangle has a length, root 3 over 2, as its base, and a height of 1/2. So we can say that this coordinate on the unit circle is just root 3 over 2, comma 1/2. And that's kind of interesting because root 3 over 2 corresponded to cosine. So we can say the x-coordinate of a unit circle is just cosine theta. And the y-coordinate corresponded to our sine. So we could say the y-coordinate in a unit circle is just cosine theta. Let's do another example. Last one. Let's say we want to find the sine of 300 and the cosine of 300 degrees. Well, the first thing we got to do is figure out where 300 degrees is. So I'm going to draw the angle. And 300 degrees is in quadrant 4. And now I got to make a right triangle. So what I'm going to do is I'm going to draw a perpendicular line straight up to the x-axis. Okay? We do not draw to the y-axis. So if you or your neighbor draws a line like this, please tell them that's not correct. Okay? Whoops. This. Okay, so our perpendicular lines always go from the point on the circle to the x-axis. All right, so now let's figure out how many degrees are left over. If I have 300 degrees, that means that this is 60 degrees, and that means that this is 30 degrees. Hey, we have a 30, 60, 90 triangle again. And, if you guys remember, the radius is 1. So let's figure out the sides. So if the radius is 1, that means this side is 2x. Remember, the side opposite 30 is x. So that means my x here equals 1. And that means the blue side is going to be x root 3. Or in other words, it's just going to be, oops, I made a mistake, sorry. X should be 1/2. Okay? Because if I solve for x from this equation, I get 1/2. And that means this side over here is going to be root 3 times 1/2, or root 3 over 2. But there's a catch. Since we've gone down, okay, in the negative y direction, this, we're going to put a negative sign in front. Okay? So it's going to be negative root 3 over 2. All right. So now we're going to calculate these. The sine of 300, we need the opposite over hypotenuse. Okay, so if I'm standing on my angle right here, okay, the opposite side is going to be, root 3 over, or negative root 3 over 2. Sorry, I was just thinking about something there. Okay. And the hypotenuse is just going to be 1 because we're in a unit circle and our radius is 1. So we get negative root 3 over 2. Okay. Cosine 300, we're going to take the adjacent over the hypotenuse. And our adjacent side was 1/2 divided by the hypotenuse is 1. And so we get 1/2. Okay, so I hope that example helps us get started, and you're now going to go finish the conquering angles journey. All right, bye guys, have a great day.